Welcome, Algebra 2. This is Properties of Exponents and Radicals. The essential question is there any difference when applying the laws of exponents to rational exponents? Let's begin. So we're going to review the laws of exponents first, just really quickly. If I had b to the m times b to the n, same base, you add the exponents right here. So in this example below, x cubed times x to the fifth is x to the 3 plus 5, x to the 8th power. Next one, b to the m to the n, you actually multiply the exponents. So if they're right next to each other like this, multiply them. So in this case right here, 2 to the third to the second power is same thing as 2 to the third times second, which is going to be 2 to the 6th power, which if you evaluate that, it's going to be 4 times 4 times 4 is 64. Next one, a times b to the m power. What happens to this is you're going to distribute that m, so it's a to the m times a to the b. So think of it like distributing this m to every term inside, or every variable and every number inside. So a to the m times b to the m. So for example, 4x cubed, I'm going to distribute this 3 to the x and also the 4. So what I'll get is 4 to the third power times x to the third power, and 4 to the third power is 64. So I can write that as 64x cubed. The last one, any b to the negative power or negative exponents, you flip it and go put it on the denominator and go b to the positive m. So whenever you switch from the numerator to denominator or vice versa, flip the sign on the exponent. So 3 to the negative 3 power is going to be the same thing as 1 over 3 to the positive 3, which simplifies to 1 over 27. 3 cubes 27. All right, we can actually apply all those to exponents that are rational. Rational means fractions, if you don't remember. So for example, in the first case, where we added those exponents, I have an example, x to the 1/4 power times x to the 3/4. So this becomes x to the 1/4 plus 3/4, and adding up fractions, you get x to the 4/4, which is the same thing as x to the 1, or just saying x. Now, b to the m to the n, so power of a power, I multiply, and I can multiply fractions. So this becomes 4 to the 4/3 power times 3/2 power. And when you're multiplying fractions, you can cancel out things that match on the bottom. So the 3's cancel out, and you can cancel out things that reduce. So the 4 and 2 both divide by 2, so I'm left with 1 down here and 2 up here. So this becomes 4 to the 2 over 1 power, which is the same thing as 4 to the second power, 4 squared, which is going to be 16. On the bottom, a to the b to the m, we can apply this distribute, this 1/2 to every term inside the parentheses, or every number and variable, excuse me. So it becomes 4 to the 1/2 power times x to the 1/2 power. And 1/2 power is the same thing as square root, so I'm going to write this as square root of 4 times square root of x. And square root of 4 is 2, so I can write this as 2 square root of x if I want to. Now, it still applies to negative exponents. So 3 to the negative 1/3 power becomes 1 over 3 to the positive 1/3 power. If I want to write that as a rational, I can write that as 1 over the cube root of 3. And sometimes I can write it like that. Let's move on. Now, we also can rewrite sometimes we want to rewrite radical and simplify. And we've done this before with a step method. So I just want to show you what this looks like if you use rational exponents. And you can do it whatever way you want. So I'm going to rewrite this as 48 x to the 5th, y to the 4th, z squared, all to the 1/2 power, referring to the rational exponent. And I'm going to distribute that 1/2 to every variable and number right there. So I get 48 to the 1/2 power, and I get x to the 5 times 1/2, which is 5/2 power, and y to the 4/2, and then z to the 2/2 power. So I want to simplify some of this. This is going to be square root of 48. X to the 5/2 power. Let's see, what else can I reduce? Okay, so I'm going to say x to the 5/2. And y, this is going to be y squared. And z to the 1 if you reduce that, so just z. And I can simplify some of this more. If I wanted to say this square root of 48, again, maybe I just go to the step method right here. So take out a 2 and get 24. 2 and get 12. 2 and get 6, 2 and get 3, pair, and alone. So that's going to become 4 square roots of 3. And this x to the 5/2 power can be written as, this is going to be an x squared times another x to the 1/2 power. I'm splitting this up, or another square root of x. And this is going to be times y squared and times z. And to clean this up a little bit, maybe the simplified form is 4x squared y squared z times the square root of 3x. So it's just to illustrate that you can convert radicals to rationals and distribute this. Let's do another one of these. Again, I'm going to write this as 8x cubed y squared to the 1/2 power. Distributing that, I get 8 to the 1/2 power, x to the 3/2 power, and y to the 2/2 power. Y to the 2/2 can be reduced, so I can write this as 8 to the 1/2 power, x to the 3/2, and then just times y. Over on the bottom one, this becomes 54 y to the 7th z squared, all of that to the 1/3 power, which can be rewritten as 54 to the 1/3 power times y to the 7/3 power times z to the 2/3 power. So they can be converted. All right? And you didn't see that, and that's it.